everyone, and welcome to the final lecture before our first exam, which is all about solving absolute value inequalities. I really suggest, hopefully by now you are starting to feel comfortable with the compound inequalities, right? Because this is just taking it a step further. So this section will be difficult until you master just solving compound inequalities. All right, so let's remind. So what is an absolute value? An absolute value is a distance, right? It is positive, right? So first of all, so for example, if I have x is equal to, the absolute value of x is equal to 3, on a number line, if I were to graph it, right, it would just be two dots at -3 and +3. All right, so this is 0. So absolute value of x equals 3. It just means that you are 3 units away from 0. Right? So keep that in mind. So before we look at the graphs of the other inequalities, I think it'll be better if we talk about the properties first. So the first property, all right, is if I have the absolute value of u is less than k. This is equivalent to writing this as -k less than u less than k. This can also be said as u is between -k and k. This also works for less than or equal to. You just put the or equals to below. So if you think about, like for absolute value of x is equal to k, remember this is equivalent to saying x is equal to k or x is equal to -k. Okay, same concept applies here. So I have absolute value of x is less than k, right? K or ux, it doesn't matter, just a variable. So if I do this, so remember in the absolute value, this is obtained by the definition, right? The definition, okay, is pretty much saying that the absolute value of x is equal to let's say x is, like, the absolute value of 3 is 3, right? And the absolute value of -3 is also 3, right? So positive or negative in this absolute value, it will spit out the same answer, right? So let's use the definition. So this, okay, I can rewrite this as x is less than k, and I can also write this as -x is less than k, right? If I divide both sides by -1 by that property, I think property 6 from inequalities says that we have to flip our sign. So this becomes x is greater than k, x is greater than -k. Okay, if I rewrote this, I can say -k is less than x. And when I notice, okay, so the reason why we just put these as between, I have -k less than x, but we also have x less than k. So you can kind of smush those together. I get -k less than x, which is less than k. Okay, this is between. All right, with this one, all right, anything if it's between like this, the compound word is and, right? It's not explicitly said, but that is it, right? And then so what about absolute value of x is greater than k? All right, same thing. So I have x greater than k, and I have -x greater than k, right? Okay, and if I solve, then I get x is less than k. This one is split between the compound word or. Okay, so when you see something greater than, it's x greater than k, or x, forgot the negative, or x is less than -k. Okay, it doesn't matter. Over here it says u is less than -k or u is greater than k. It doesn't matter what you put as long as it makes logical sense. Right. Again, this also works for greater than or equal to. So now that we talked about like the general property, what does it mean? So if I have the absolute value of x is less than 3, right? If you look at this graph, okay, it's between So that means the distance of x has to be less than 3. Okay, so let's think about like growing up and playing in the neighborhood. Like your mom might say, or your dad might say, you cannot go past this street, right? That is essentially saying, or like you can't go past these two streets. That's essentially like a absolute value inequality. You have to stay within, okay, your street. All right. And then what about when the absolute value is greater than 3? It means that you want to find a distance of x that is greater than 3. So an example of this one would be like a restraining order. If you were given a restraining order and they said you cannot be 50 feet within this within a certain person, right? So from you to that person is a no-go, right? But anything 50 or past is okay, right? And you can see that illustrated in the graph, right? Since they're colored on the outsides. Okay, hopefully that made sense. Yeah. So, and again, the solution set is, the first one is the set of all x such that x is between -3 and 3. And the other one is the set of all x such that x is less than 3 or x is greater than 3. All right, they got these right here by just by using the property of absolute value inequalities. All right, so now let's start doing some examples. All right, so first we want to solve for this. So the absolute value of u is less than or equal to 7, right? So remember the absolute value inequality, the property of it, right? So since we want the distance less than or equal to 7 units, right? We want to stay in between. So this is equivalent to saying -7 less than or equal to u less than or equal to 7. Okay. I was making your test and I noticed that the test asks for the interval notation first. Right, so if you want to go ahead and sketch the graph like on your own piece of paper, that's completely fine, right? I would, just because it's easier to visualize the interval notation when you see it. Okay, and then also the test. So we've been using open or closed circles. In this one, they use parentheses or brackets, right? But same concept. If for an interval notation, if you use the bracket for like the or equals to, right, you're gonna do that with the graph as well. Right, so since u is between -7 and 7, what does that mean? It is right here. Okay, so our interval notation is -7 to 7. Right, and then if I want to draw the final graph, right, make sure you pick the right spot. Okay, and it's all of this right here. Right, so that is the first problem. For the second problem, we have the absolute value of t plus 15 is greater than 20. Right, so first things first, this is just pretty similar to solving absolute value equations. All right, you always want to isolate the absolute value. So whether you see it as an equation, as an inequality, you gotta solve for the absolute value first, right? So this is not isolated, so I have to subtract 15 from both sides. When I do that, I get t. If I subtract 15 from both sides, I get is greater than 5. Now that this is isolated, all right, what we're going to do is we're going to rewrite this in its equivalent form. So absolute value of t greater than 5, what does that mean? That means we want to find all the distances of t when it's greater than 5. Right, all the values of t that make the distance greater than 5. So I have t greater than 5 or t is less than -5. Okay, if you have trouble remembering, this is something I would learn, okay, but again, if you have trouble, okay, as long as you understand for the absolute value, whether inside is positive or negative, it spits out the same answer. You could solve it as if I did up here. Right, the only thing is you'll have to understand that when it's less than, it's the word and. This one is or. All right, and that's why I think it's just better to memorize the property. So again, okay, if you want to sketch a little graph before you find the interval notation, that's fine. Okay, if we do that very quickly, I have -5 and 5. We have 5, t greater than 5, so it's all of this, and t less than 5, which is all over this. All right, I did an open circle because it's strictly less than. Again, you can also use parentheses. Right? So what would the interval notation here be? Remember, we go from left to right. So when I start from the left, I notice it's colored right away. So what does that tell me? This tells me this is -infinity. I keep going, and I notice there's a stop at -5. It is not included, so I'm going to use a parentheses. Okay, I keep going. I notice all this blank, so we're not going to write it. And then I notice we start at 5. Okay, so we're going to have 5, and it goes to infinity. Okay, when you have two intervals, you have to combine them with a union. Right? What is that? What does the union mean? The union means that our solution, all the values of t that make this true, is from the interval -infinity to -5, and it also includes 5 to infinity. These both of these intervals are our solution. All right, so let's graph it. So I have this, and then it goes on. And then we have 5 to infinity, and it goes on. Right? You don't have to put parentheses over here, all right? Because since it goes to infinity, all right, it just gets drawn endlessly. Okay. I do think it's kind of dumb on the test they don't let you graph it first, because personally I would like to graph it first, but it is what it is, right? So, and this is number 2. Let me copy this again. Okay. For our third problem, okay, we are given the absolute value of g plus 29 is less than or equal to 15. Right? Again, we have to isolate g, so we have to subtract 29 from both sides. When I do that, I get -14. Right? If I subtract that, then I can do just 29 minus 15. Right, I get 14, and because the 29 is bigger and we're subtracting it, we keep the negative. All right, so if you're looking to the left, you obviously see the answer. All right, but let's explain why. So again, what is the absolute value? The absolute value is the distance. All right, if there's nothing in it, it means the distance from 0. Right? What is the distance? It is always positive. Right? So absolute value of g, no matter what you plug into here, this is going to be a positive number. Okay? So you have a positive number less than or equal to -14. Can this ever happen? No, it cannot. A positive number will never, ever, ever be less than or equal to a negative number. Because of that, this is no solution. Okay? It is the empty set. It is nada. Okay? So, the solution set would just be empty braces, and the graph itself, because there is no solution, there is no such g that will make this inequality true, this whole graph will be empty. Okay. So now number 4, very similar to number 3. Okay. The only thing is I have the absolute value of g plus 29, but instead we have greater than 15. Again, we have to isolate the absolute value before we do anything. So I'm going to subtract 29 from both sides. Like above, this is -14. Right? So again, what is the absolute value? The absolute value is a distance. It is a positive number. Right? Any positive number. It's just great. So ask yourself, a positive number greater than -14. When is this true? This is true for all real numbers. Right? You even pick 0, you pick 1. Right? 1 is definitely greater than -14. 0.0001 is greater than -14. Right? A positive number will always be greater than a negative. What does this mean? This means that our solution is the all real numbers. The solution the interval, okay, or they even call it the solution set, right? The interval, this is interval notation. Alex also recognizes this as the solution set, right, is negative infinity to infinity. And if we were given a graph, right, if we had to graph this, what is this? Since it's all real numbers, that means every number that you pick on this graph, no matter what, okay, we pick negative a million, 200, 3.14, doesn't matter. It will satisfy this inequality. All right. So now let's go one step further. Okay. Let's do number 5. All right, number 5, as you can see there, it's not just one just a variable in the absolute value. We have like this y plus 2, right, less than or equal to 4. Again, this is still a distance. Okay. So when I solve for this, y plus 2 less than or equal to 4, again with the absolute values, we have to make sure our absolute value is isolated, right? So as we can see, it is isolated, okay? So now we're just going to rewrite this in its equivalent form. Its equivalent form, so the absolute value of y plus 2 less than or equal to 4, I can write this as y plus 2 being between negative 4 and 4, okay? And then we carry the signs, it's less than or equal to. All right, when I see this, okay, I have to do every single thing. So I have minus 2, I have to minus 2 here and minus 2 here. All right, this is like a 3-part inequality. All right, so we got to keep all 3 of them balanced. All right, so negative 4 minus 2, that's negative 6, less than or equal to y, less than or equal to 2. Right, so what is this saying? This is saying that y is between negative 6 and 2. So the solution set, right, is negative 6 and 2. Okay, if you're unsure of that, okay, you can go ahead and sketch the graph first. Okay, the reason why I know this is because like you can pick any y, but it has to be below. Or it has to, sorry, not below, it has to be between. Right, so if you wanted to do a little sketch, okay, you're going to find y greater than or equal to negative 6. It's going to be over here. Right, you could go past here, and then y is less than or equal to 2. Okay, you could go past here too. But because when it's between, this is an and. Since it's an and, right, then it can only be these values. Right, these are the only values that would give me an x. Right, so let's actually draw this on as our real solution. Right, and it's over here. Right, let's do one more example, and we will call it a day. Right, our final example, we're given 2d minus 5 is greater than 7. Again, first things first, doesn't matter, inequality, equation, whatever, if we see an absolute value, we have to isolate it. Right? Luckily, it's isolated for us, so we can just rewrite it in its equivalent form. Right? So this is greater than, so this tells me this is going to be 2d minus 5 greater than 7, greater than 7, or 2d minus 5 is less than 7. Or less than negative 7. Right? Okay. So let's go ahead and solve. So I'm going to focus, just like solving compound inequalities, I'm just going to focus on one inequality at a time for solving. So I'm going to add 5 to both sides. I get 2d greater than 12. And then I get, d greater than 6. Right? Bring these ors down. Okay, over here I will have 2d less than negative 2. I have d less than negative 1. I never had to switch the signs because I divided by a positive number. Right? So again, and this is, so honestly, probably the reason why like for this, the equivalent form, they put u is less than the negative or u is greater than the positive k, is so you can go from left to right. Right? I usually just like to copy down what's up here first and then switch the sign. Again, not a big deal. Okay. So we want to write the solution set first. Okay. Ideally, we would graph first. Okay, like put the final graph. But since that's not what they're doing for your test on Alex, we're gonna practice it this way. Right? So I have d greater than 6 and I have d less than negative 1. So first I'm going to graph the negative 1 and 6. Alright, so I have d greater than 6, so it's open because it's strictly greater than, and we're going to go over here. For d less than negative 1, again it's open, and then we're going to go over here. Since it's an OR is a union, so everything we see, so remember that this Venn diagram, it is everything. Everything in it is colored. Right? So what does that mean? So everything that we see here that's on the graph, whether it overlaps or not, is a solution. Right? The only time it's not a solution is when nothing's colored, which is between 1 and 6. Right? So what is the solution set? Okay, or interval notation. Okay, it's negative infinity to negative 1. Negative 1 is not included, so I'm going to put a parentheses. Okay, I'm going, and I notice that there's more that's going to be added, so I'm going to put a u. Okay, 6 is also not included, so I put a parentheses to infinity. Right? Remember that if you don't go from least to greatest, right, you will be counted wrong. Okay, so let's draw the final graph. Okay, so over here, so our final graph is going to look exactly like our sketch. Okay, I'm going to put the parentheses here, right? Remember, parentheses is the same as open dots, and it's going to go to infinity, right? So I'm just going to color this whole thing, and then go to 6, and also color this whole thing. Right? So that is it for the absolute value inequalities, right? And then we'll do all of these class problems on Wednesday.